Hi everyone, so this video contains a simple solution for our problem A of code forces round 976. So the problem name is find minimum operation and we are provided with two integers n and k. So in one operation we can subtract any power of k from n. Formally, let's say if you have n this and you can pick any power of k and subtract it from n, and such that it won't get negative, right? Because our target is to make n 0 and we have to find the minimum number of operation to make n 0. So one thing to clear is that every time we can make n 0, right? Because let's say if you pick k raised to the power 0, then this will become 1, and when you subtract 1 multiple times from n, you can obviously make it 0, right? This will take obviously n operation, but we want to make n equals to 0 in minimum number of operation, right? So yeah, so our problem A, and we have n and k. So let's pick an example, right? So let's say if our n is 7 and our k is 2, so like what can be powers of 2? Let's take some example, right? Power of 2, if I pick one series, let's say 1 2 4 8 so on, right? So let's take a simple approach, right? If you are solving this problem and you have this series of 2, basically the power of 2, and you want to subtract this from 7 so that our 7 gets 0, right? Our n will become 0, and you have to do this in minimum number of operations. So obviously you will think that I should subtract it with a largest number, right? So if I subtract it with 4, let's say in step 1 I subtract 7 minus 4 and our number becomes 3, right? Now in step 2 I have 3. I cannot subtract it with 4, right? Because if I subtract it with 4, it will become negative. We don't really want that. So in step 2, just subtract this as number step 1, step 2. In step 2, we will subtract 3 by 2, right? It will become 1. And finally, in step 3, I'll do the same. And our 1 minus 1, this will become 0, right? So here this takes 3 operation. However, let's take an example. What if this would have been, let's say, 9, right? Then you will start subtracting from 8, right? Then our n will become 5, and then you will subtract by 4 and so on, right? Now this can also happen sometime that you wanted to subtract by the largest number, and you can do this multiple times, right? Because every time our target is to subtract n by the largest possible power of k, right? So we can apply a greedy approach here. Like you can understand, we are being greedy here, right? We always want to pick the largest power of k, and then we want to subtract it by, like, subtract it from n, right? So the solution to this, basically there are multiple solutions this particular problem. We can also use bit manipulation, but here we will be using a simple greedy approach, right? Now I will show you the code for the same. So like this is my boilerplate. You don't really need to get diverted from this. Just focus on the solution here. So first we just take the input of n and k, and I just make a vector v for storing the power of k, right? We don't really need to store so many powers of k. We can only keep track of up to our power is getting greater than n or not, right? So I'll just initialize my vector with 1. So this 1 represent k raised to the power 0, obviously. Then I have a loop goes to 1 to 100. We don't really need to wait till the 100, because as soon as our power will become greater than n, we'll simply break it. And this variable power, just keep tracks of the power of k, and we just every time multiply it with k, and we'll populate this into our array, and then we have our answer initialized to 0. Now every time I wanted to see the greatest power of k, which I wanted to subtract from n, so I will reverse this array, because currently this array contains the power in increasing order. I want the greatest power first, right? That's why I reversed my array, right? Now I will just simply iterate my array, and if I found at any index my current power of k is greater than n, then this is not really use for me, right? Then I will just continue this iteration, and if this is not the case, then I wanted to see how many times I can multiply, how many times I can subtract this from n, right? So I can elaborate this part. Let's say picking an example here. Let's say if my number n is at some iteration, if my number n is 15, right? And I want to subtract it with let's say some power of k. Let's just pick in this case 4, right? Just this is a hypothetical case, and this 4, let's say if my some point my case some power raised to the power x is 4, and I want to subtract it, right? So I can subtract it once, it will become, now I can write it here. So 15 I will subtract once, it will become 11. Then I can subtract it again, it will become 7, right? Then I can subtract it again, then it will become 3, right? So there are four number of times I can subtract this. So not really 4. So 15 to 11 this is 1, and 11 to 7 this is 2, and 7 to 3 this is third. So there are basically 3 number of iteration happen for a single index of k. So how can we keep track of this? We can simply get it by the division, like how many times the perfect division can happen between n and the power of k. So let's you pick the example here. When n is this and you divide it by 4, so what's the whole number you get? You get a 3, right? When we floor it down, and like C++ already floor it down, we don't really need to do anything here. Otherwise you can also for the sake of understanding, you can write like this. You can make a floor operation here, right? And what is the leftover value, right? You are left it with 3 here, so this can be achieved by this. So I think you folks already know this will give us the floor quotient value, and this will give us the remainder value, right? So here this is the remainder value I left with, and I will initialize it with my new value of n, right? And this iteration will goes on, and finally we will have our answer. So let's just try this particular code on a certain example, right? So let's pick an example here. We have in question, so we have in question these many examples, right? You can just pick, I can just copy this, I'll compile my code, and I'll come back to this screen. I'll paste this test case. So this is our solution, correct one. And like you folks can also even implement this particular code from yourself, and you can try to submit it, right? Thanks.